What you have to keep in mind while studying all these 5 laws are that first you have to remember the name of the scientist who proposed it. Second, you need to be able to define or state the law, right? And you should be able to illustrate it with an example. From whichever source, whether it is the natural origin or the synthetic origin, the ratio between the atoms will be always a constant. The statement for the law of conservation of mass is, matter can neither be created nor be destroyed. Hello everyone, I am Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today we are starting with session 3 of your chapter, Some Basic Concepts of Chemistry. So in last session, we have discussed about uncertainty in measurement, scientific notation and significant figures, right? So in today's session, we will be discussing on laws of chemical combinations, under which you have to study 5 laws that are law of conservation of mass, law of definite proportions, law of multiple proportions, LUSSAC'S law of gaseous volumes, Avogadro'S law. Yes, and then we'll be moving on to the next topic, that is Dalton's atomic theory. Then we'll be discussing on atomic mass, average atomic mass, molecular mass and formula mass. Yes, so let us begin with the laws of chemical combinations. Yes, so what does this mean? Laws of chemical combination. Why is it that necessary? So in the study of chemistry, we know that, of course, there are chemical reactions that are taking place. So whatever chemical reactions takes place, they have to follow these laws of chemical combinations that we are going to study now. See, let's take the example where you are studying in a school or college where you have to follow the certain rules and regulations which are put forward by your school, right? You are supposed to follow that rules and conditions, right? In the same way, the chemical reactions also need to follow these laws of chemical combinations, right? Yes. So let's begin with the first one, that is law of conservation of mass. So as I said, we'll be discussing 5 laws here. So what you have to keep in mind while studying all these 5 laws are that first you have to remember the name of the scientist who proposed it. Second, you need to be able to define or state the law, right? And you should be able to illustrate it with an example. Okay, so let's begin with the first one, that is law of conservation of mass. Okay, so this law was proposed by Antoine Lavoisier in the year 1789. Okay, so the scientist who proposed this is Antoine Lavoisier. So he performed experimental studies for combustion reactions and reached to the conclusion that in all physical and chemical changes, there is no net change in mass during the process. So let it be a physical change or chemical change that is happening in a chemical reaction, there is no net change in mass during the process. Yes, the scientist Antoine Lavoisier was able to conclude from his experiment that let it be a physical or chemical reaction, there won't be any change in mass before and after the reaction, right? So the statement for the law of conservation of mass is, matter can neither be created nor be destroyed. Yes, matter can neither be created nor be destroyed. Yes, so let us take an example. Yes, hydrogen gas combines with oxygen and forms water. Yes, so if I balance the equation, it will be like this, right? Yes, 2 molecules of hydrogen gas combines with oxygen to form 2 molecules of water. Now we are going on with the mass, right? So 2 molecules of hydrogen means it is 4 gram, right? And oxygen gas 32 gram. And you know that 1 molecule of water means it is 18 gram into 2. That will be 36 grams, right? So if you add the mass of the reactants, what it is, 32 plus 4, that is 36 grams which is equal to the mass of your product, right? So there is no mass created nor destroyed in this case. What was the mass before the reaction is equal to the mass which is after the reaction. That is, your mass of the reactants is equal to mass of products. So from here you can say that mass can neither be created nor be destroyed. So now let's move on to the second law, law of definite proportions. Now this law is given by the French chemist Joseph Proust. Yes, a given compound always contains exactly the same proportions of elements by weight. This is the statement that he made according to law of definite proportions. What it is? A given compound always contains exactly the same proportion of elements by weight. What does this mean? So the experiment that he did is, he worked with two samples of cupric carbonate, one which is of natural origin and other one which is synthetic, right? So when he worked with cupric carbonate, one natural origin and one synthetic, he was able to conclude that from whichever source, whether it is the natural origin or the synthetic origin, the ratio between the atoms will be always a constant. So let us take the example here of water, right? So from any source you are taking water, let it be from the lake or from another country, wherever it is, the ratio between your hydrogen and oxygen will be always 2:1, right? So let us take the example of carbon dioxide. Yes, from any source or any chemical reaction you obtain carbon dioxide, the ratio between carbon and oxygen will always be a constant. Right? So that is what the statement says here. A given compound, so let's take a given compound, that is your water, always contains exactly the same proportion of elements by weight. Yes? So always the proportion between your hydrogen and oxygen will be 2:1 in the case of water. Right? So he concluded that irrespective of the source, yes, irrespective of the source, from wherever you are obtaining your water, a given compound always contains same elements combined together in the same proportion by mass. Yes, I hope it is clear. Now let's move on to the third law, that is law of multiple proportions. Yes, now this law was proposed by John Dalton in the year 1803. So the statement for the law is, if two elements can combine to form more than one compound, the masses of one of the element that combines with the fixed mass of the other element are in the ratio of small whole numbers. Yes, so this statement or definition might be a little confusing. So let us take an example and clarify it. Yes. So, what does the first part says? If two elements can combine to form more than one compound. Yes. So, in this example, you can see hydrogen combines with oxygen to form water. Yes. In the same way, hydrogen combines with oxygen to form another compound, which is hydrogen peroxide. Yes. So, that is clear. Now, the masses of one of the element that combines with the fixed mass of another element. Yes, so you can see the mass of hydrogen is fixed here. Here also it is 2 gram, here also it is 2 gram. Yes, the mass of hydrogen is fixed here, right? So, the masses of one of the element that combines with the fixed mass of other element. So, the mass of hydrogen is fixed here. So, the mass of the oxygen in here is 16 gram and here it is 32 gram, right? So, there is a difference. So, the other element are in the ratio of small whole numbers. Yes, so the element which is combining with the fixed mass of another element, that is oxygen in this case, the ratio between them will be small whole number. Yes, so the ratio between the masses of these two, that is 16:32. I can simplify it and write it as 1:2, right? Yes. That's clear. So that is what is meant in this statement. That is, if two elements can combine to form more than one compound, yes, as you can see, water and hydrogen peroxide is formed, masses of one of the element that combines with the fixed mass. Fixed mass here is hydrogen. It combines with oxygen. So the ratio between the masses of the element which is not fixed here, the ratio between the masses will be in simple whole number ratio. Yes, I hope it is clear. Yes, so now let's move on to the next law. Now, this is regarding gaseous volumes. Yes, Gay-Lussac's law of gaseous volumes. So, from the name itself, you can understand who is the scientist that proposed this law. Yes, it is given by Gay-Lussac in the year 1808. So, the statement for the law is, when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. Okay, so even this, let's take an example and understand this. So you can see the example here. 100 ml of hydrogen combines with 50 ml of oxygen to give 100 ml of water vapor. So volumes of hydrogen and oxygen which combine bear a simple whole number ratio, that is 2:1. So let us say, from the example you can see, hydrogen combines with oxygen to form water vapor, right? Yes. So it is given in here that 100 ml of hydrogen is combining with 50 ml of oxygen and it is giving 100 ml of water vapor, right? So you can see the volumes which is given here is in simple whole number ratio, right? Yes, 100, 50 and 100. How can you write it? 100 is to 50 is to 100. So that is in the ratio 2:1:2, right? Yes, they are combining in a simple whole number ratio, provided all gases are at the same temperature and pressure. Then only this will be applicable, right? So you can also write it in a way, yes, here you can see it is 2. So 2 volumes of hydrogen combines with 1 volume of oxygen. Here no coefficient is present, that means 1. So 1 volume of oxygen and it forms 2 volumes of water. Again you can see the ratio here is 2:1:2. Yes, under same temperature and pressure. Yes, so I'll read it out again. When gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume. See, the ratio between the two gases is 2:1, provided all gases are at the same temperature and pressure. Yes. Now let's move on to the last law that we are going to study here is Avogadro's law. Yes, from the name itself you can get to know who is the scientist who proposed it. It is Avogadro. So this was proposed in the year 1811 by Avogadro. Yes, so the statement here is equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Yes, I'll read it out again. Equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. So what does this statement mean? Let us take an example and understand it. Okay, so under same temperature and pressure conditions, I am taking two different gases. Let us take hydrogen and oxygen gas. And I am taking equal volumes of hydrogen and oxygen gas. Yes, let us say I am taking 1 volume of hydrogen gas and 1 volume of oxygen gas. So, according to Avogadro's law, if I am taking equal volumes of two gases, let it be any different gases, if under same temperature and pressure conditions and equal volumes, they should contain equal number of molecules. So the number of molecules present in your hydrogen and number of molecules present in oxygen will be equal. Yes? Yeah. So from the example you can see 1 volume of hydrogen combines with 1 volume of hydrogen and 1 volume of oxygen to form 2 volumes of water vapor. Right? So from this you can see 1 volume of hydrogen and your 1 volume of oxygen. Yes, if it is taken under same temperature and pressure conditions, provided they are having equal volume. See, you can see here 1 volume of hydrogen and 1 volume of oxygen. Same volume, same temperature and pressure conditions, they will be having the equal number of molecules. Yes, so this is about the 5 laws of chemical combinations. I hope till here it is clear. Now let's move on to the next topic, that is Dalton's atomic theory. So these are the postulates which were proposed by Daltons according to his experiments, right? So in 1808, Dalton published a new system of chemical philosophy in which he proposed the following. So from his experiments, he was able to formulate these postulates. So let's go one by one. So the first postulate is matter consists of indivisible atoms. Yes, so this was the first postulate made by Dalton's atomic theory. So as of now, we know that matter is made up of atoms which are divisible, right? There are subatomic particles, electrons, protons and neutrons. Yes, so this is actually not applicable in the current scenario, but these were the postulates which were made by Dalton in his Dalton's atomic theory. So you can see that some of these postulates were wrong. Okay, so the first one is matter consists of indivisible atoms. Yes, all atoms of a given element have identical properties and mass, and atoms of different elements have different mass. Yes, so atoms of given element, same elements are said to have same properties and mass, and atoms of different elements have different mass. This was the second postulate. Now coming to third one, compounds are formed when atoms of different elements combine in a fixed ratio by mass. Yes, compounds are formed when atoms combine in a fixed ratio by mass. Now next one is chemical reactions involves reorganization of atoms, and these are neither created nor destroyed in a chemical reaction. So he said that in a chemical reaction, the atoms reorganize with each other, and he also mentioned that atoms can neither be created nor be destroyed. Yes, so Dalton's theory was able to explain the laws of chemical combination that we just discussed now. The Dalton's atomic theory was able to explain it, but he couldn't explain the law of gaseous volumes. Yes, he couldn't explain the law of gaseous volumes, but the other laws he could explain it using his Dalton's atomic theory. So these were the postulates which were proposed by Dalton, out of which some are not correct or true according to the situation now, right? Yes, so atoms is divisible. We know that atoms is not indivisible. Atoms are actually divisible. That is, electrons, neutrons and protons, subatomic particles are present in it. Next one, atoms of same element may not be having similar properties. Yes, we have studied about isotopes. So in Dalton's atomic theory, it was given that all atoms of a given element have identical properties, right? So it need not be true always. Atoms of same element may not be having similar properties always. Yes, an example for it is isotopes, right? Yeah. Now atoms of different elements can have similar properties. Yes, this is also opposing to Dalton's atomic theory. Yes, isobars are such type of substances. Yes. Now, the ratio in which atoms combine is always not in simple ratio. Yes, what does the Dalton's atomic theory says? The compounds are formed when atoms of different elements combine in a fixed ratio by mass. Yes, that need not be simple always, right? And the last one is mass of atom can be changed to energy. Yes, this equation E is equal to mc square. So, it is clear from here that Dalton's atomic theory has its own limitations, right? Now, let's move on to the next topic, that is atomic mass. So, from the name itself, you can understand what are we going to discuss here? The mass of an atom. So, what is atomic mass? It is basically the mass of an atom. So, how do you find the mass of atom? How do you find the mass of atom? So, you can imagine that matter is made up of atoms. So, just imagine how small the mass of atom will be. So, it is difficult to measure the mass of the atom. Nowadays, you have methods in which you can measure the mass of atom, which is called as mass spectrometry. But earlier, you didn't have these methods, right? So, what did we do is atomic mass, to calculate the atomic mass, it was related with something. That means in certain cases, if you want to say the mass of an object, yes, if you want to identify the mass of an object, you relate it with something. So, relating to the mass of the pen, the mass of this is more. Yes, so you are relating with each other. Same way, to find out the atomic mass of your atom, that is the mass of your atom, it was related with some other element. So, earlier hydrogen being the lightest atom was chosen as a reference. Yes, as I said, the mass is related with something else. So, earlier hydrogen was your reference. right? So the mass of your atom was compared with the mass of your hydrogen. But nowadays, hydrogen is not considered as your reference. The present system considers carbon-12 isotope as the reference. Okay, it considers carbon-12 isotope as the reference. So now the question arises, how to find the atomic mass? How do you calculate it? We know that the reference that we are going to use here is carbon-12 isotope. Yes, so let's see. So the unit used to measure atomic mass is atomic mass unit. So it is defined that one atomic mass unit is 1/12th the mass of carbon-12 isotope. So the reference we took here is carbon-12 isotope. So your one atomic mass unit is 1/12th of your reference. That is 1/12th of your carbon-12 isotope. Yes. So nowadays your AMU is replaced by U, which is known as unified mass. So instead of representing it as atomic mass unit, it is represented as unified mass with the symbol U. So now let's calculate what is the mass of your 1 AMU. Yes, so mass of these many particles of carbon atoms is 12 gram. That is 6.022 into 10 to the power 23 particles of carbon atoms, 10 to the power 23. Yes, particles of carbon atoms is 12 grams. Now, what will be the mass of one atom of carbon? Yes, these many atoms of carbon is having 12 gram. So, one atom of carbon means 12 divided by this value, right? That is 6.022 into 10 to the power 23. So, then what will be your 1 AMU? We know that 1 AMU is defined as 1/12 the mass of carbon-12 isotope. Yes, so that means we multiply this value 1/12. We multiply the value by 1/12, which is written here. 12/12 into 6.022 into 10 to the power 23, which gives you this value 1.661 into 10 to the power minus 24 grams. So this will be equivalent to your 1 AMU. Yes, or you can say 1 U. Yes, so this is how you find out the value of your 1 AMU. So we can say that what will be the atomic mass unit of hydrogen? What is atomic mass of hydrogen? You can say 1 U. What will be the atomic mass of oxygen? It is 16 U. Right? Yes. So I hope till here it is clear. Yes. Now let's move on to the next part, that is average atomic mass. So now what is the need of finding average atomic mass? So when we take into account the existence of isotopes and their relative abundance, the average atomic mass of the elements can be computed. So let us say we know that hydrogen is having 3 isotopes, right? H11, H12 and H13. Yes. Protium, deuterium and tritium. These are the 3 isotopes of hydrogen. So if I ask you, what is the atomic mass of hydrogen? Would you say the atomic mass of this one or this one or this one? Yes. In such cases where there are isotopes present, you need to find out the average atomic mass. Right? So let us take the example of chlorine. Yes. So there are 2 isotopes of chlorine which is present. Yes, chlorine 35 and chlorine 37. And the percentage abundance is given. Yes, how much percentage of 35 chlorine is present and 37 chlorine is present is given here. And their masses are also given. So how do you find the average atomic mass? What you have to do is, the percentage abundance is given here. It is in percentage. So you have to divide it by 100. So 75.77 divided by 100 multiplied by the mass of your isotope of chlorine, that is 35 chlorine mass. It is given here 35.9689 plus what is the percentage abundance of 37 chlorine? It is given here as 24.23. As we said, it is in percentage. So divided by 100 multiplied by 36.9659. So when you do the calculations, you will get the value as 35.45. Yes, so this will be the average atomic mass. So you need to multiply the natural abundance with the mass of the particular isotope and add it. Yes, that is what is you can see here, right? Yes, I hope that is clear. That is average atomic mass. Now let's move on to the next one, that is molecular mass? Yes, it is a very simple concept. It is the sum of atomic masses of the elements present in a molecule. Yes, so the atoms present in a molecule, you have to add the atomic mass of each atoms present in a molecule. So it is obtained by multiplying atomic masses of each element by number of its atom and adding them together. So you can see the example of methane here, CH4. We know that the atomic mass of carbon is 12 and there are 4 atoms of hydrogen present and the atomic mass of hydrogen is 1. That is, atomic mass of carbon is 12 and there are 4 atoms of hydrogen, that is 4 into 1, which will give you 16U. Yes, now let's take one more example. Let's take the example of carbon dioxide. So it is 12. What is the atomic mass of carbon? It is 12 plus 2 atoms of oxygen. That means 16 into 2, that will give you 44 grams. Right? So this is a simple concept how to calculate molecular mass. It will be the sum of atomic masses of the atoms or the elements present in a molecule. Yes, clear? Now let's move on to formula mass. So basically formula mass and molecular mass are calculated in the same way. But what is the difference between molecular mass and formula mass? So formula mass comes into existence when there are ionic compounds used for the substances which does not contain molecules, like in the case of ionic compounds. Yeah? So these are used in the case of ionic compounds. So you can see here sodium chloride. It consists of Na plus and Cl minus ions, right? It is an ionic compound. Yes, in the case of CH4, it is molecular mass because it contains molecules and atoms, right? In this case, ions are present, hence we use the formula mass. But the way in which you calculate the formula mass or molecular mass is the same. So formula mass of sodium chloride is atomic mass of sodium plus atomic mass of chlorine. So what is the atomic mass of sodium? 23. And atomic mass of chlorine is 35.5, which will give you 58.5 U. So you calculate it in the same way as molecular mass, but it comes into existence in the case of ionic compounds. So yes, what is the difference between formula and molecular mass? It is the sum of atomic masses of the ions present in the ionic compound, and molecular mass is the sum of atomic masses of atoms in a molecule. Clear? So this is obtained from empirical formula and this is obtained from molecular formula. Yes, molecular formula might be similar for you. What is empirical formula? Yes, regarding this in detail, we'll be studying in our next session. Right? So till here, what we have discussed, I hope it is clear for you. Yes, in the next session, we will be discussing on mole concept, molar mass, percentage composition, empirical formula and molecular formula. Yes, so that's all for today. Thank you.